Before we start into doing our acid-base notes today, we're going to talk about term 4 final project. This is a project that we've come up with and done several years in a row, and it works really well. You become the teacher in this project, okay? And we go over things that we've already learned. So you can break up into a group of either 1 to 4. So if you don't like working in groups, you can just be your own self. If you like working in groups, then you need to make sure that your group works really well together, because you're going to be graded on how well your group works together. Okay? So you can choose your group. Your job is to look at the takeaways, those chemical takeaways that I gave you, and choose a section that you'd like to present again. That you'd like to say, you know, I know some really cool stuff, or my dad does some really good cool stuff, and he can teach me how to do whatever, or mom. Get something that you'd like to do. But once a standard or objective is gone, it's gone. So as soon as you get through and you look through the objectives and you see what ones you might want, make sure you come up and get it cleared with me, because once it's gone, it's gone. So some ideas. This is not all of the things that you can do. It's just some ideas, and I've given to you, I think. So maybe I want to do nuclear. That's where those standards are. Or light spectrum. Or maybe bonds. Or maybe chemical reactions and stoichiometry. Or maybe thermal chemistry. Or maybe rates and reactions. Or maybe equilibrium. Or solutions and colligative properties, or acid base. There's a lot of things that we've covered. Please put the phone away. Thank you. So you choose what one you want to do. Okay? When you get your topic chosen, your standard objective, you're going to come up to me, and there is a place for me to stamp front and back, so I need to stamp both of them. That says that you're approved and nobody else has that, and then that topic is yours. There's also a place on the front for you to put your name and phone number. Now, I thought I copied this in yellow, but it's copied in white. So it's that one page that you have that's one page, both front and back. So I'm just going through the front part of that right now. Okay, so this front side is basically for you to write on. Use your imagination, make it fun. Okay, you are the teacher. Your group is the teacher. You need to make or download a video. YouTube will not run at the school on your account. So if you want to use a YouTube video, you've got to download it at home and then bring it in. Okay, please try it before your presentation. Make sure that it runs, so that when your presentation comes, you're not, oh, well, it worked at home. If it doesn't work here and it's part of your presentation, then that's a 0. So make sure it runs beforehand. PhET is also a great place to look for simulations to make it fun, more involved. Your group will have 30 minutes to present. If you think you need more than 30 minutes, let me know. I'm going to give you a week to research, and then next week I'm going to ask each group, okay, how much do you think time you need? Okay, once I get the times from you, then I'll set the due dates for each of the groups. Now, I've had groups in the past that have used the whole period. That's great. That's wonderful. They've taken us outside to the football field to do something, or they've taken us in back to do something. Be inventive, okay? Make it fun, make it exciting. But remember, if you have more than one person in your group, the percent participation for each person, each member, is also related to the percent of the final grade. This is going to act as a test. We'll have 2 other tests. That means there's only 3 tests this term. You're in charge of 1, totally. You can decide how well you're going to do on this test. You have got a rubric on the right-hand side that is written down. And you can go through each of these. So you can go through and see how much each is possible. You can decide, if you're doing a group, who's doing it, and who the helpers are. So who's in charge of making sure it gets done, and who's going to help for that one if you're going to do a group. So you need to make sure that you go through each of these. So you've got a presentation. Everybody should be involved in the presentation. It should be enthusiastic, not just up here. I feel like the Peanuts, you know. All right? Content. Somebody needs to make sure that you actually are covering the objectives and standards that you said you were going to do. Okay? Because if not, then you got to realign your group and say, hey, wait, we missed this. So put somebody in charge of that. PowerPoint, Prezi, or some kind of presentation. You can make your own video here. That's okay. But you can make a Prezi. You can make any kind of presentation, but it needs to be some kind of presentation, so we sort of get in our head again what those standards and objectives are. Okay? Demonstration. You need to have some kind of demonstration. It needs to be cleared with me, especially if it's a chemical demonstration. If you need chemicals and you want to do a demonstration, we need to go through it a couple times before you do it in front of the group. Okay? I want to make sure it's safe and that nobody's going to get hurt. Okay? A video or simulation. This is different than this. If you do a video up here, this still is a different video. This is a video or simulation in which it's real world. Okay, in which you take us in, how is this applied, kind of thing. Okay, we've had in HASTA, we had one person that took and went to her dad's work, and he did a bunch of polymer stuff, and how bonds are formed, and plastics and stuff like that, and went through and videoed what he did at work and how that related to the bonds. Okay, that was cool, but that came into here, not here. Okay, does that make sense? All right, job applicability, job. Don't just say scientist or chemist, okay? That is too overarching. It covers too many things. You've got to be a lot more specific, okay? I can't even say an organic chemist anymore because there's so many branches underneath organic chemist. What kind of organic chemist? Okay, does that make sense? So you've got to be very specific on your jobs. Reference pages must include 5 references. Okay? I don't care if they're book, I don't care if they're internet, I don't care if they're people, but you've got to have 5 references, and it's got to be written so that I could go up and look them up. Okay? Demonstrated teamwork. So if you're working in a team, I've got to see that you're all working together, that you're all part of the presentation, that you're all taking equal parts, that you all know what's going on. Not that Joe Schmo showed up and said, okay, what's my part? And didn't do anything of the presentation. Goodies are extra credit, but they have to tie into the topic. So in other words, if I'm talking about light, I can't give Twinkies because they don't relate. Okay? I've got to have some way that they relate. So actually on this test, you could end up with 110%. That would help your other tests, right? Because tests are more. All right. So on the back side, you've got another little place that has your topic, standard, objective, presentation date, and a place for me to stamp it. That's so I don't have to keep flipping back and forth. So everything's on one side when it comes back to for grading. The other side is yours. You can write on whatever you need to write on, but this side is for me. So you're going to fill this in except for the stamp, and you'll fill in the presentation date when I give it to you. Then you're going to fill in who's in my group and give me some abbreviation initials. The day that you turn this paper into me is the day you give the people in your group a grade. Did we all participate 100%? Did we all give our all? Or did, Joe Schmo show up that day and he hasn't done a thing? I don't think that, at least this is my experience with group projects, I don't want to be the one that does all the work and have Joe Schmo get the credit for all my work. That's not fair. Okay, so we want to make this fair. So if you choose to a group, then this is where I'm going to score you. Out here on this side right here, there's a blank area. You can go ahead and put initials here of who you think should be doing these parts for me, but I'm going to actually use the initials that you did, and I'm going to use here who actually I saw participating. So when I get done, I'm going to look at this and say, okay, did all of them take equal parts? And if not, I'm going to divide the grade that way. So I'll take and say, okay, as a group, they got 110. But Joe Schmo, I only saw 5%. So 5% of 110, that's what his grade's going to be. Okay, does that make sense? Okay. All right. Questions with the project? Yes, ma'am.
So on the video, you said we could use a song. Can we use a song that you've shown us in the past?
Yep, you bet. You bet. Or if you find a better one, great. This is sort of where I get lots of new ideas for next year. And I'm seeing how you guys have related it. So this is a good review, and it's a good bring it together. In fact, I'll tell you a story real quick. I had one student that had F's all the year through, and he shined at this, got 110%. Plus, I mean, he was just amazing. He did one on light and on waves and talked about waves. He had built a a tube with holes in it and put a glove on the end and then hooked it to propane and then lit it. So that you had this fire up here. And then on the end you put sounds, because sound waves are a lot like light waves, and you could see, you know, the waves in the flames. And then for his treat, we roasted marshmallows over the flames. So, and depending on where you were on the flame, because he still had the sound going, sometimes you get burned. But it was fun. And it was amazing because he had gone through and done his research, and he had a lot of hands-on stuff for us to do. And it was amazing. And he took the whole period. I was like, whoa, where have you been all year? It was amazing. All right, so any other questions with that? Yes, ma'am. If you do work alone, then I just give you are your own team. Okay? And I, you know, sometimes it's nice to, he did it all by himself, and I was like amazed. It was wonderful. Okay? All right? Any other questions with this? So what I'm going to do is once we go to daily work, I'm going to have you have a chance to come up and tell me what you want to do. Okay? Yes, ma'am.
So if we do it by ourselves, would like the participation be like 100% since we're doing everything?
Yep. Yep. Yeah, unless you do a horrible job with yourself.
I'm hard to work with.
You're really hard to work with. Okay. All right. Any other questions? All right, here we go. Get your notes out. We're going to do notes now. So you've got your guided notes. This is day 1. I'm going to get my favorite pen up, and we'll begin. All right, so there was a lot of vocabulary that we need to learn. So the first one we come to is hydronium and hydroxide ions. Hydronium is written as H3O+. Okay? That's a formal way. A lot of times you'll see it as just written as just H+. Either is acceptable. Okay? Hydroxide ions we've worked with before, those are OH-. All right, now, as we talk about different types of acid-base definitions, I like to think of like a bullseye. So here I have a bullseye, and there's 3 levels of the bullseye. We're going to worry about the inner 2. The outer one is Lewis. Wait a minute, we've heard that word before. What did he do? Lewis dot. And so if you go on to CE or AP, you're going to go and talk about Lewis's definition of an acid base, because it has to do with the Lewis dots. But we're not going to do that here. It's a little bit more vague. We're going to work with the second one, which is Bronsted and Lowry, and the center one, which is Arrhenius. So you'll notice I like the bullseye effect here because Arrhenius defines just a small amount of the acid and bases. Bronsted-Lowry defines a bigger amount of acids and bases. But Arrhenius defines our strong acids and bases very well. So we're going to talk about how Arrhenius defines acids and bases. So he says acids are hydrogen plus donors. Okay, so they have to have a hydrogen to give away. And bases are OH- or hydroxide donors. Okay, so we look at this, wait a minute, water plus water equals a hydronium and a hydroxide ion? You're telling me my water is acid and base? What? Well, water does what we call, or what is an amphoteric, I forgot the H. Let's do this again. Amphoteric compound, which means depending on who it's with, it can act as an acid or a base. It always likes to neutralize a situation. So if it's with a group that's acidic, it acts like a base to neutralize the problems and sort of make things work. If it's working with a base, then it becomes a little bit acidic so that, you know, it can neutralize the situation again. So it's like one of those friends that does well with this group and does well with this group. Does that make sense? Okay, so here we have an acid, and here we have a base, And here we have an acid. It would be a conjugate acid, and we'll talk about that just a second. And this is a conjugate base. Whoops, J. Anybody have an idea of what conjugate might mean? On the first side, I just put acid and base, right, reactants. On the product side, I put conjugate acid and conjugate base. Did anybody notice the arrows? What was those arrows? We just did an equilibrium lab. It can go forward or backwards, right? So when it goes forward, my things on my reactant side are my acid and base. But if I'm in the products and I want to go backwards, I put a conjugate in front because I need to know which side these acids and bases are on. So conjugate just means I started on my product side and I went to my reactant side. Okay? All right. As we look at this, this is another way right here to look at the equation up above without saying there's two waters. Basically, it says, yeah, I'm going to split the water up and it's going to become an H plus and an OH minus. We're going to have an acid and we're going to have a base. Let's go on a little bit more. So, who can tell me what that first equation is? Is it showing me an acid or is it showing me a base from the definition of Arrhenius? Okay, why do you say an acid? Okay, so it doesn't have an OH minus, it has an H plus, so it is an acid. I can look at just the HCl and say, oh, it has a hydrogen, so it must be an acid. Okay, what about the second one? Why do you say it's a base? It's got an OH, so I can say this is a base because it will produce an OH. I can also look at the original and say, oh, there's an OH there, so it's probably going to be a base. All right? Let's look at a couple more. Now, that's pretty easy. If I'm trying to identify an acid and base with Arrhenius, it's like, okay, it's got a hydrogen, it's an acid. It's got a hydroxide, it's a base. Pretty easy. Bronsted and Lowry says, okay, that works for most of them, but there's a bunch out there that don't have an OH, that are bases. So what they said, because it's two different guys, they did separate research and ended up, sometimes only Bronsted gets credit for it, but Lowry did it at the same time, kind of thing. So acids here are considered proton donors. What is a proton? Well, isn't that, because if I have an H plus, that means the electron's gone away. That means the only thing that's left is the proton because hydrogen didn't have a neutron. So when I'm talking about a proton being donated, I'm basically talking about an H plus. Okay, but this is a terminology they use, is proton donor. On the base side here, its bases are proton acceptors. Remember, the proton is H plus. Okay? So let's look at some other equations here. So as I look at this going from side to side, what gave off a hydrogen? What gave off a hydrogen from the reactant side to the product side? H2O. So if I'm looking from here to here, H2O gave off a hydrogen, right? So it would be my acid. All right? Who accepted that proton? NH4 actually got the proton. It started with NH3, so this is my base. Now, thinking going backwards, which one's going to donate going backwards? A proton. NH4, so this is going to be my conjugate acid, and OH will be my conjugate base. Now, Now, I wrote these in the same color that's tied together because these are known as conjugate pairs. So my blue is a conjugate pair. My red is a conjugate pair. So if I'm asked for a conjugate pair in an equation, I look. Now, if it says an acid conjugate base pair, then I know which one I'm looking for, right? Or if it says a base conjugate acid pair, I know which one I'm looking for. Okay, because there'll be ones like that. All right, let's go on. See if you can identify what's your acid, your base, your conjugate acid, and your conjugate base, and get your pairs. Try. No clue. Which one's losing a hydrogen from side to side? Which one starts with a hydrogen and it doesn't have it on the other side? That would be your donor, which was your acid. The one that accepts a hydrogen from left to right is your base. Okay, I'm going to have you guys help me label this, so if you're not understanding, make sure you're asking. Okay. So if you go from, where are we right here? So this has a hydrogen, but over here it does not. So because it doesn't, this right here is going to be my acid. That means this has to be the, and this doesn't have a hydrogen now, so now it has to be a conjugate. What?
So it would be the acid conjugate? Or conjugate acid?
Let's see. Be the conjugate base,
Oh, okay.
right? Because it needs to gain a hydrogen.
Okay.
You'll notice that there is a little issue with the CLO. It should be CLO2 with a -1 on yours. They got flipped, and they're both superscript. The 2 should be subscript. Okay, and that should be your conjugate acid. And then hook your pairs together. Okay, make sure you hook your pairs together. All right, back row. Deja, tell me one thing to label. Acid, okay. Okay, tell me one thing to label. It is the base. Okay, tell me one thing to label. This? Okay. Okay. And? Good. Good question. You tell it by, you're going to go backwards. Which one's going to give up a hydrogen coming backwards? That's going to be the acid. Which one's going to accept? It's going to be the base. Okay, now, tie them together for me. Give me one pair that goes together. Pick another one.
Oh, wait.
Right. Okay, because it gave off just one hydrogen, so. Okay. All right, Jacob, give me the last one. What to connect? All right, good. All right, so we've got one more. Let's do it. Front row, you're on the spot this time. There are some issues, so make sure you're fixing the issues while you're looking up here because there's some issues with the actual thing. I think the 4 is up instead of down and something weird in the notes, sorry. Yeah. Okay, just a few more seconds and I'm going to ask you to do it. Yes, Jade. We're going to be working on the next set of notes. We're going to be working on assignment 2. We'll be also working on the acid base thing right here, the blue one. So you can grab one of those. Okay? Those of you that aren't going to be here. All right, we ready? Okay. Peyton, I'm going to start with you. Tell me one thing to label. HCl is the what? Acid, yes. Okay, give me something else. Yep, that's the base. Okay. Oh, you can't sleep. Come on. Give me one more thing. Which one is? This one doesn't have a hydrogen or proton to donate. So this is a conjugate acid. Okay. All right. Good. Connect a pair. HCl and the Cl is a pair. Good. Connect a pair. The other two. Only ones that are left. Okay. All right. So pretty good so far. Are we getting this? Understand it pretty easy? Okay. We'll have some more practice. Okay. So here I've been given acids. And I want to show what the conjugate base would be. Okay. What does an acid do? Gives off a what? Hydrogen. So I'm going to lose a hydrogen. And a hydrogen has a what charge? Positive. So I'm going to lose a hydrogen and a positive charge. So for this first one, what is its conjugate base? HF, no plus because I got rid of one. Okay, what about H2SO4? What's its conjugate base? HSO4 negative because I lost a positive. Okay, so I took away a hydrogen that had a positive, and now I've got an extra negative that's not balanced. Okay, what about HNO3? Yes. Yes, it would be. Yes, Jade. Yeah, what is it? Yes. Good job. Okay, do we understand why? Okay, we just give off a hydrogen and that's a positive. So if it didn't have a charge overall, then when I lost a positive, I now have an extra negative that's not balanced. Okay, that makes sense? Okay, so now we're going to look at the bases. What if I have a base and I want to find the conjugate acid? Well, what does a base do? Add an H. And what does an H have? A positive. So what's the first one going to be? NH4, because I added a hydrogen, and it has an extra positive. Good. Now this right here is an acetate ion. This is an organic way to write it because it just tells us the structure. So it just says hydrogens go around that carbon. There's a carbon here, double bound oxygen, single bound O with that. We've been using it as C2H3O2 minus. That's the inorganic way. If you go on to organic chemistry, which is a half-year class next year, you can take and learn how organic compounds go together. Just a way. So how would I do this next one? I would actually go inorganically. This is how I would write it. Okay. I just put the H in front just like normal. This is my polyatomic. This C2H3O2 is a polyatomic. It's a group hangs together. I can't enforce somebody to go in the center, but they can attach. And if you look at it up here, the hydrogen actually comes in and bonds right there.
Is there a positive at the end?
No positive because it had a negative.
Yeah, so it can't do that.
Excuse me. What?
I don't know. I think
Say it again.
well, like if there's stuff around it, like the H,
Mm-hmm.
is that where you have to add it?
Mm-hmm. Right. Right. Okay. So what about this next one? Yes. No. Oh yes. Sorry. Okay, so what about next one? HPO4 minus 2. Good. What about the last one? Good. All right, going forward. So strong acids will completely ionize, completely go into their ions. Weak acids don't. Notice the difference here. Yeah, it's not a very good one. Okay, so when I'm talking about strong acids, and you want to add this here, it 100% ionizes. 100% goes to the product. Okay? But for weak acids, only 1 to 5% go to the product. So 100% here, 1 to 5% here.
There's like no in between.
Well, there's some that are in between, but we still consider them weak. Okay? Right. Okay, so strong bases, what do you think is going to happen here? Same thing, 100%, 1 to 5%. Okay? That's pretty easy. All right, so going forward, here is a trick I'm going to teach you. There are 6 strong bases and 6 strong acids. And you need to be able to look at the periodic table and be able to remember them. Okay? So, we're going to do bases first. How many have ever played Tetris?
Oh.
Okay, you know the shape? This is an extended Tetris prep. It goes basically like this. Okay? These are our bases. So let's identify what they are. We start with lithium, then we go to sodium, potassium, and then calcium and strontium, and barium. Okay? What? Okay, so right here, the first column is a +1, so we're going to add 1 hydroxide to it. So it'll be LiOH, NaOH, KOH. The second column is a +2, so we add 2. So Ca, parentheses OH, parentheses 2, Sr, parentheses OH, parentheses 2, and Ba, parentheses OH, parentheses 2. Some of the books say these 2 are also strong, but we usually don't include those because they're not very common and they're really hard to get. And because they're not really common and not really easy to get, we don't use them a lot. So, okay. All right. The other ones are the acids. Bases are on the left, acids are on the right. And in acids, we have oxyacids, which have oxygen with them, and we have binary acids, which don't have oxygen with them. We're going to talk about the oxyacids first. Those are this one, and this one, which are nitrogen, sulfur, and chlorine. Now, when I said oxyacids, they have oxygen with them. So the nitrogen has 3 oxygen and is a -1. Sulfur has 4 oxygen and it's a -2. And chlorine has 4 oxygens. Try that again. 4 oxygens and a -1. So you'll notice the top row that we have the nitrogen on has 3 oxygens. The second row has 4 oxygens. They have -1 on each side and -2 in the center. So we have HNO3, which is nitric acid, H2SO4, which is sulfuric acid, and HClO4, which is perchloric acid. These are my oxyacids that are strong. Okay, we also have 3, and I'm going to add a yellow here so you can sort of see. We have 3 binary acids. Binary means 2, just hydrogen and one other thing. It is chlorine and the 2 below it. So the 2 below it are bromine and iodine. So we have HCl, HBr, and the friendly unfriendly acid, HI, that will tell you hi and then eat you alive. Those are binary. Now, remember binary acids, we start hydro. So hydrochloric, hydrobromic, hydroiodic. Okay, remember on the oxy acids, I gave you a little trick before Thanksgiving. I said, remember if the polyatomic stays in 8, if it hits my stomach acid, it's going to go ick. So the H just tells me it's acid. And then the polyatomic is what I look for. I look at the name. If the 8 is, if it's an 8 ending, then it just goes ick and acid. So top one would be nitric acid, sulfuric acid, perchloric acid, because they were all 8s. Now, had they been an ite, does anybody remember the trick for if the polyatomic was an ite? Oh, us, we're going to get in a fight. So if it ends in ITE, then we change the ending to OS and add acid. Almost every single one, in fact, I think every single one of the OS acids are weak. Okay? Because you're weak if you get in a fight, right? That's right. Okay. Signature block.
Yeah, here's on your email, because I'm sending the email with the letter.
Oh, just S. Howell. I just do Stacy Howell and what?
Classes.
Oh, classes.
I need a formal signature block, because I'm putting both of
I
ours.
don't know how to send you that.
Can you send me an email? Doesn't it I've looked at some of the ones you've sent me.
Okay.
Yeah, so
I
I
can
need that. I have it in a draft, and I've got the Word document that I'm going to send out to the CTE coordinators about
Okay.
chemistry.
I'll work on it next period. Is that okay?
Yeah, and then
Okay.
send it to me, and then I'll send it out.
Okay. All right. Okay. So we've got this. Now, there's a little thing that you have a chart that has them all on it with their names. So hopefully you remember them. I've given you a trick of how to remember them on a periodic table because you'll have a periodic table on the test, but you won't be given these names. Right? So this is a trick to remember them that I just gave you. All right? That's the end of the lecture today, but I'm going to add a couple things to it. Would you grab out your daily assignments? Because there's been a couple on the daily assignments that have had the kids struggle. Yep, stumped you. Okay, so look at the second page on the back of the first page. And it is halfway down. Okay. Halfway down, you start seeing things that ask you to write a balanced equation for the dissociation or ionization. There's two ways you could do this. So the first one you have there is HClO4, right? I'm going to show you both ways. You can choose which way you want to write it. When it's added to water, we can just add water, and one of them has to act as an acid, one of them has to act as a base. And if I look at HClO4, that's one of our strong acids, right? So I would use a strong forward arrow, right? If it wasn't one of my strong acids, I would use a forward and backward arrow, because that would mean it was weak. On the other side here, I'm going to get ClO4 minus, and I'm going to get H3O plus, and I'm done. Okay? Now, the other way that you could write this, okay, remember sometimes I show water, sometimes I don't, would be to say HClO4 is a strong acid, and it's going to dissociate into an H plus and a ClO4 minus. I don't care which way you write it. Okay? Now let's go down to, that was number 5A. Let's go down to number 6, C. 6C. So this one is BaOH2. It is a strong base. Now this one I would not add water. It makes it really hard because most of the strong bases are solids. So when we put them in water, sometimes we just put water over the arrow. You'll see it that way. Okay, just saying it's put in water now, so it's going to dissociate. When it dissociates, we're going to get the charge. We know we have 2 OH minuses, and we have 1 barium that's in the second column over, so it's going to be a +2. Now, I'm sort of a stickler about this, but you do what you need to. This was a solid. Anytime you have an ion, it's AQ, meaning aqueous, dissolved in water, but I also say it's a cute little ion. So anytime there's an ion, it should have an AQ. Okay? Now there's one other, so flip over the page. So I'm giving you some examples in each area. And we're going to do 10D. Okay? On 10D, we've got magnesium hydroxide plus, what do we have? Phosphoric acid. So we're going to probably have this going on because magnesium hydroxide is not a strong base. The little thing under it. Oh, yeah, add the other one on. Yep, that's good. Okay, so now we have to go back to how do I balance equations? How do I write equations? How do I finish the equations? This is a review part. Do you remember? Oi, not that again. There's a hint. Oi, what did I say? Outsides and insides, right? Oi. Oi, it's chemistry. Outsides and insides. So you're doing a double displacement, yes. So this is going to go with this, and this is going to go with this, right? We need to know the charges. Hydroxide was a -1. Magnesium's a +2. Hydrogen's a +1. I have 3 of them, so phosphate must be a -3. Okay, so now on the other side, I'm going to put those together. So magnesium is going to go with phosphate. So Mg, which was a +2, and PO4, which is a -3, those are not going to add together to equal 0. So how many of each one do I need? Because 3 times 2 is 6, good, and that would make a -6, then they would add together to equal 0, right? Okay, and I add to that H and OH, which makes H2O, always. H2O. H and OH always make water. Okay, now I got to go back and I got to say, okay, erase all my little helps. And what do I need to do? Is it all right the way it's written right now? What's wrong? I got to balance the thing, right? So 1 magnesium on this side, 3 magnesiums on this side. What do I need to do? Add a 3 right here. Okay. I'm going to skip the oxygen, hydrogen to last, right? Oxygen very last. So then I'm going to go to the phosphorus. I have 1 phosphorus, 2 phosphorus. Put a 2 in front of that. Now I'm going to look at my hydrogen. Okay, I've got 6 here, and I've got 6 here. So that's a total of 12. I need 12 over on this side, so I need to put a 6. Good. Okay, now I'm going to look at my oxygens. So I've got 2 times 3 is 6. 2 times 4 is 8. 8 plus 6 is 14. Okay, I've got 2 times 4 is 8 plus 6 is 14. I'm done. Okay? All right, so that section right there is a review basically of double displacement. Now you'll notice almost every single one of them because they are what kind of acids and bases in that section? Arrhenius. Arrhenius, because it has an H and an OH, right? So that's Arrhenius definition. You're always going to make water as one of them. You're always going to make water. So you can do H2O, and then you just do the other one to do your other. Okay, time is yours to work as needed. You're assigned assignment number 1. Remember, you still got that pH packet and your review packet that need to be done. So if you get done with your other stuff, you should be working with those. And then you need to come up and tell me what you want to do for your project. So take time, look at your Common Core, and come up and look at it. If you're done with your POGL, turn it in, yes. And don't forget to turn in your lab. Okay, your pH lab, home lab. All right, we're good.